Hi there, my name is Dimitris Haralapidis, and in this video, which is actually a part of a bigger series of videos focused on AP Precalculus, we will be continuing exploring the syllabus. We are in Unit 1, which contains around 30 to 4% of the entire AB exam weighting. We are in the prerequisite part of that unit. We are discussing about relations, about functions. And in this particular video, we will remind ourselves the definition of a function. In the previous video, which I urge you to watch all videos in the exact order I have placed them in YouTube, we previously discussed some definitions, and these were the definition of an ordered pair, the definition of a relation, input, output values, domain, range, and we classified relations. Now, we will go one more step, and we will define a function. A function is a special case of a relation in which every input value is connected uniquely to an output value. Once again, a function is a special type, a special case of a relation in which two things occur. Firstly, every input value is used, and this input value is connected uniquely to an output value. Let's see some examples. We have this one, A, B, and this is the Greek letter gamma. Let's call it ABC for now. And at the right, which is supposed to be the range of that relation, we have the values 1, 2, 3, 4, 5. Now, we must be entirely precise. What we say with regards to definitions in math is that they are too strict. A definition only applies when we can follow it entirely. What did we learn about the definition of a function? That every input value. Does this apply here? No, it doesn't. This, every input value, here, it's not met. So this means that this relation is not a function. Let's move to example 11. Again, we have A, B, and C in the domain, and then we have numbers 1, 2, 3, 4, and 5 in range. Every input value, is this condition met? Yes. A is connected, B is connected, and C is somehow connected. Uniquely, however, connected. Does this apply here? Well, this thing doesn't. A is connected at the same time to 1 and 2. This cannot define a function. So, once again, not a function. Not a function. Example 12. In the domain, we have numbers 0, 1, 2, and 3. In the range, we have 2, 4, and 9. Every input value. Is this condition met? Yes. Uniquely connected. Is this met? Well, let's take them one by one. 0 is uniquely connected to 2. So here we are okay. 1 is uniquely connected to 4. 2 is uniquely connected to 4 again. And 3 is uniquely connected to 9. That should be a function. Hold on, some might say. 1 and 2 are both connected to number 4. How can this be a function? Remember what I said earlier. Definitions are strict. Do we have the every input value being involved? Yes. Is every input value uniquely connected to an output? Yes. Were we told that what we see in example 12 cannot happen? Were we ever told in the definition I gave you earlier that different input values should be addressed to different output values? No, there was never such a thing in the functions definition. So there shouldn't be a problem here as well. When I was in your age, I don't know your exact age, but I assume that you are students. When I was in your age and I was learning about functions, I used to have this simple example in my head. I thought of functions as if placing books in shelves. We can take lots of books and place them on the same shelf. Exactly what happens here. We took number 1 and 2 and placed them to number 4, but we cannot take one single book and place it into 2 different shelves. What happened in example 11. And that would be all. This was a short video in which we just discussed, we just reminded ourselves of the definition of a function. If you found this video helpful, please do not forget to subscribe and hit the bell so that you don't miss the next lesson. As always, thank you for watching and thank you for your time.